Hey, what's going on, folks? All right, so what I'm going to do is try to explain this thing called extraneous solutions. And to be honest with you, it's not a very popular term. I haven't heard it used very much before, and I think it's kind of an archaic term as far as it's not used much in today's mathematics. But I'm looking at the solution, and I can kind of see where this text is going with this one. So the question is asking you to solve the square root of x minus 3 plus 4 equals to 1. All right. The first thing we're going to do is we're going to isolate the square root. We're going to take this square root and get it all by itself. And in order to do that, we're going to subtract 4 from both sides. That's pretty standard. All right, so we got square root of x minus 3 equals, what do you call it, negative 3. Cool? All right, so now what we're going to do is, in order to get rid of that square root, if you have the square root of k, and you want to get that k out of there, then what you need to do is multiply by the square root of k again. Now the square root of k squared, because notice there's two k's, is simply equal to k. And so what's happening here is all we need to do is multiply both sides by this square root of or I mean not multiply both sides, but we need to square both sides. So what we have here is x minus 3 equals to 9. And then we can simply solve for x by getting it all by itself, and you have x is equal to add 3 to both sides, and you get 12. Now there is a caveat as far as you need to make sure that you check your work, and that's really important. So I'm going to put a little check box here and check the work. And so let's plug in 12 into our original answer and see if we get an answer. And so you have the square root of, well, all I do is I plug in a 12 wherever I see an x now. So I'm saying, does 12 work? So 12 minus 3 plus 4 equals to 1. And let's see. 12 minus 3 is 9. So the square root of 9 is equal to, or plus 4 is equal to 1. And so you have 3 plus 4 is equal to 1, and then this is saying 7 is equal to 1. And you're saying, wait a second, what's going on? This doesn't make any sense at all. Why? When does 7 equal to 1? And the answer is it doesn't. And so therefore, x is equal to 12 is an extraneous solution. Is that what we call it? Extraneous solution. And I don't think that the text, or I haven't seen a whole lot of people give a really good explanation as far as what does that mean? Why do we get these extraneous solutions? That doesn't make any sense at all. And I'll tell you why, okay? If we were to go back to what we call graphical transformations, I could graph this thing in a graphing calculator, but you know what? I think this would be a great opportunity for me to show you a little bit about graphical transformations. So, if we had, and this is going on a side or a tangent a little bit, so that way we can kind of talk about some graphical transformations and how they work and all of that kind of stuff. So if I had f of x is equal to x squared, I would have this thing called a parabola. And now if I had f of x plus some number like 3, what that would be is that's x squared plus 3, and we know how to graph that. That is actually a parabola that has been moved up. Actually, you know what I'm going to do is I'm going to change color. I'm going to go like this. If I had f of x plus 3. This is x squared plus 3. And what that gives me is a parabola that has been pushed up 3. So if I add something to the outside, that will move the graph vertically. Whereas if I had f of x plus 3, that would give me x plus 3 squared. Now what this one does is this moves it, you guessed it, if the other one moves it vertically, this one's going to move it horizontally. And I'll tell you now, when you're moving things horizontally, it's going to do something a little bit funky in that the plus 3 kind of makes you imply that it's moving it to the right 3, when actuality it moves it to the left 3. And I'm hoping that you've seen this before. So the original graph is this black one that's super important. It's super important to know what that graph looks like. And then the transformed graphs is the purple one and the blue one. And I can move things around depending on that. And I can even combine this. I can even say, all right, well, what is f of x plus 4 minus 2? Okay, well, that's x plus 4 squared minus 2. And so I know, actually, you know what? I'm going to do a x minus 4. I'm sorry. Let's use the eraser real quick. Pen. I'm going to do a minus 4 just to show you something a little bit different. I know that, okay, the regular parabola looks like this. And my new parabola is going to be 4 to the right. So 1, 2, 3, 4, and 2 down. 1, 2. So it's going to be the same kind of parabola deal, just like that. All right. So what does this have to do with our problem? Well, I'm showing you this so that way we can kind of get an idea. If I say, hey, let's graph this thing, the square root of x minus 3 plus 4. And I'm just going to set it equal to y for now. And I know you're saying, wait a second, you set it equal to 1 over here. And we'll get there. Give me a second. But let's set it equal to y so we can find what the graph looks like. And I'll tell you what the graph looks like. Okay, so first I got to show you what, if y is equal to the square root of x, then I'll tell you what that base graph looks like. Okay, what that looks like is it almost looks like a half parabola that is flipped on its side. I'll show you what the graph looks like. It looks kind of like that. That is the graph of the square root function. And if you don't believe me, I'll make a small table for you real quick. It's pretty simple. You have x and you have y. If x is equal to 1, then y is equal to, what's the square root of 1? It's 1. If x is equal to 4, then the y is equal to 2. If x is equal to 9, then y is equal to 3. So you have 1 and 1 right here. And you have 2, 3, 4. And this thing only goes up to 2 right here. And you go way out to 9, and it goes only up to 3, so it's way out there. So this is your square root function. All right, but we graphed y is equal to the square root of x. We didn't graph y is equal to the square root of x plus 4. So I don't get exactly what my original graph is, but I'm getting closer. So what that's going to do is it's going to take my graph and make it move up 4. So I'm going to have a parabola that is, say, all right, I didn't draw this out with a good plan. Okay, 1, 2, 3, 4, and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm going to have my new parabola is going to be, I'll do it in purple here. And the last part is, well, actually, it's not the square root of x plus 4. What you need to actually graph is the square root of x minus 3 plus 4. What that's saying is you're graphing, if this is equal to f of x, then what you want is f of x minus 3 plus 4. All right, so that implies, just like how what we were doing with the parabola up there. What the actual graph of this thing will look like is up 4. It's going to be your standard square root graph, but it's going to be pushed up 4. So 1, 2, 3, 4, and across 3. 1, 2, 3. So this, and I'm going to erase that purple graph, but this blue graph is actually what our graph looks like. And when we set that equal to 1, because our original problem was the square root of x minus 3 plus 4 is equal to 1, what that's asking is, okay, if y is equal to this thing right here, and we set that equal to, or when does y equal to 1? The number 1. And what the math is trying to tell you is, look, you're asking me, when does this blue graph ever touch this black dotted line? And the answer is, it doesn't. It does not touch that black dotted line. However, Mr. Math is saying, right? This here's where the extraneous answers come from. The graph is saying, well, actually, this is, I told you, it looks like a half of a parabola turned sideways. And that's because x squared is not equal to, but it's somehow related to the square root of x. It's actually related to both. What we usually do is the plus and minus of the square root of x. So all I graphed was the plus of the square root of x, but I could graph the minus of square root of x, and then it would literally look like a parabola that is flipped sideways. And what the computer is telling you, and it doesn't look like in the graph that I drew, maybe because I drew it a little bit ugly or whatever, but what the computer is telling you is it's saying, if this graph were to have the other half of it, then it would cross that line. And I'll tell you exactly where it would cross that line. It will cross that line at x is equal to 12. So that's where that x is equal to 12 is coming from. And that's why you're getting an answer that doesn't actually make sense. You're getting an answer of, up here, we got an answer of x is equal to 12, and you said, oh, good, we're done. And then you checked it, and it said, wait, that doesn't make sense. It will do that when x is equal to, or when 7 is equal to 1. And then you say, wait, there's no solution because 7 never equals 1. And what this thing is saying is, yes, there is no solution. And you know what I mean? And here's the backstory to all of it. Because your graph actually looks like this, and you're asking me, when does it cross this line? You see extraneous solutions a lot in physics. And what I mean is, I feel like I understand why it's called extraneous solutions when I do a lot of physics, is because you ask the question of, a lot of times you'll ask the question of, here's a cliff, and you take a ball and you throw it up in the air, or you take a football and you throw it up in the air, and or at least if you're from a different part of the world, if you take a football and you kick it into the air, because you know you're a soccer player, it will go like this. And when you solve that quadratic equation, you're gonna end up with an answer that says something like time is equal to 5 comma or time is equal to -2. And what we usually teach these physics students and these math students is to say, that doesn't make any sense at all. Well, at least the -2 doesn't, because we're talking about a time. And how does the time equal to 5 and -2? And so we just say -2 is an extraneous solution. We throw it out. Doesn't need it. But in actuality, what the math is telling you is that it's saying, hey, this is a parabola, and with the input that you've given me, I don't know anything about the cliff. All I know is that it started here and it goes up and down. Math is all about symmetry, so it continued in its brain. Well, I mean, math doesn't really have a brain, but I'm just saying, like, this is what's really going on, is it continued that part of a parabola into a full parabola, and it's telling you it will reach the ground at time is equal to 5 seconds, and also time is equal to -2 seconds. To say that if I were to, because the question that you ask is, when does the parabola touch the ground? And the answer is, well, it's technically on the ground, or at least it's technically at height equals 0 at 2 separate times. And that's the quote unquote extraneous solution that it's giving you. And then in the practical physical world, you need to say, well, wait a second, -2 is not actually an answer that makes sense, because there's no such thing as negative time. That's similar to what's going on here. This is saying, if I were to continue this graph like this, then I can give you a solution, and that's at x equals 12. But you need to say, wait a second. I mean, the easiest thing to do in the world would just be to do what we did here and stop. And that's actually the right thing to do, even though I told you all about this extraneous solution and where it comes from and why we're doing it and all of that kind of stuff. What's the real thing that's happening behind the scenes here? You don't need to do any of this stuff that is outside of this box that you don't need to do any of this stuff or any of this analysis. I'm really just trying to explain to you where this comes from and what's going on behind. What's the motivation behind all of this? But what this is saying is, it does have a solution, and then you as a thinker need to go in and say, wait a second, that solution might not make sense. And when you plugged it in to the actual problem, it doesn't make sense. But keep in mind that see this graph right here, the graph of a full plus or minus the square root of x, that is not a function. Because a function, and that's why the real solution only included the top half of that graph. And then the real solution says there is no solution. Because if I were to add the bottom half of this graph, it would no longer be a function. And a function is defined as, at any given x, it only crosses through one point. So we run this thing called the vertical line test. And we say, okay, here's an x value, and it can only cross at one point. Well, it's good for that black graph, but if I had the black graph extend to the bottom part, it would no longer be a function because it's crossing at 2 points. I know I covered a lot, and I'm going to probably be teaching more on graphical transformations later, but I wanted to kind of explain to you what this extraneous solution thing is all about, because it can be quite confusing at times. And after reading the text, I'm like, I don't necessarily know if they did a very good job at all with explaining where this thing comes from or what's going on behind the scenes. All right, let me know if you need any more help. Thanks so much for your time.